In this video, we're going to be trying to multiply and divide really big numbers. So we're going to learn how scientific notation can make this an easy process. All right, so really already, if you were trying to multiply 20 million by 42 billion, written in decimal form like that, you could just type those in on the calculator and do it, I'm sure. But this one would be easy to do by hand, because what you can do is just multiply the 42 by 2, get your 84, which is easy to do in your head, and then throw all those extra zeros on there. So the first one had 1, 2, 3, 4, 5, 6, 7 zeros, and the second one had 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So I need to have a total of 16 zeros on there. So I'm going to get a pretty huge number, but it was quick and easy to do, and there it is. Well, we're going to learn to multiply big numbers, to consider multiplying by big numbers by maybe putting them in scientific notation first. That's almost what's going on when you use this shortcut for multiplying. Because like that first number, let me go ahead and write the 20 million. So that's 1, 2, 3, 4, 5, 6, 7. And then the 42 billion. Okay, so what I could do is I could say, well, that's 2 times 10, and the decimal's understood to be here, but I want it there. And so what I'm noticing is that would be 3, 6, 7 spots. And it's a big number, so it's a positive 7. And then this one would be 4.2 times 10 to a power. Decimal's understood to be there, and I want it there. And so that's 3, 6, 9, 10 spots. And so if I'm trying to multiply these, what I can do is multiply the 2 times the 4.2, which would be 8.4. Doubling 4.2 would be 8.4. And then I could multiply the 10 to the 7th and the 10 to the 10th, and here's where the exponent rules come into play. These have the same base, which is 10, and so then I could add the exponents and get 10 raised to the 17th power. And so in scientific notation, this number would be 8.4 times 10 to the 17th power. So scientific notation can enable me to multiply pretty quickly. All right, so notice here's the 3, 6, 9, 12, 15, 16, 17 places. I would have had to move the decimal to get it from there to there, okay? All right, so your job is going to be able to find a product normally by writing things in scientific notation if they're not already, okay, and then doing the multiplying by utilizing this idea here, okay? All right. So if the numbers started out in scientific notation, then what we can do is take the 3 times, multiply the 3 times the 2.2, okay? Right, and then take your 10, you have your 10 to the 5th, and you're multiplying that by your 10 to the 3rd, okay? So those exponents would get added, and then you just do 2.2 times 3, and you'd get 6.6. And that one's nice and straightforward, because 6.6 does only have one place to the left of the decimal. So this really is in scientific notation, and we're done. But this sometimes happens, and it can cause a problem. So I want you to really concentrate with me on this one. So here, what I can do is take the 5 times the 7, Okay. Then take the 10 to the second times 10 to the third. So when I do 10 to the second times 10 to the third, that means I have 5 tens, so 10 to the fifth. And then the 5 times 7 is 35. The problem is 35 doesn't fit, doesn't have just one place to the left of the decimal. The decimal is understood to be here. So that's really kind of in this intermediate form. It's not scientific notation and it's not decimal form. So if I want it in scientific notation, I'm going to have to make an adjustment. The decimal right now is there, but I need it to be there, right? So the 35 I had would really be 3.5 times 10 to the first power. But I already had 10 to the fifth. So if I need it in scientific notation, this one I need to do that extra little step, which people sometimes forget to do. So that would equal 3.5, and then we have really 10 to the first, 10 to the fifth. We really have it times 10 to the sixth. Okay. All right, so people struggle a lot when that happens. And sometimes we'll put a 10 to the fourth instead of a 10 to the sixth. So here's a good way to do it. What I just showed you is to take the 35 and write it in scientific notation. Then combine the two powers of 10. Okay. But some people might do something like this. They might take that 35 times 10 to the fifth, which means you'd have 5 zeros there at the end, and then they go from there back to scientific notation. And they see, oh, okay, so I'm going to have 1, 2, 3, 4, 5, 6, right? So you need a way of doing that and understanding that it's going to be 3.5 times 10 to the sixth when you're finished. Okay? All right, another thing you could think too is 35 needed to be made smaller. So like when I'm doing that, 35 needed to be made smaller by 1 decimal place. So I'm going to like balance that out by adding 1 to the 5. Okay. All right, let's try a couple more. Here, I'm supposed to find the product, and then it says I can round the decimal part of my answer to 2 decimal places. So I'm going to do the 3.25 times the 5.1, and then I'm going to do the 10 to the negative 4 times the 10 to the negative 3. Okay? So the 10 to the negative 4 or 10 to the negative 3 have the same base, so I could add those exponents and get a negative 7. Then I'm just going to do the 3.25 times the 5.1 on my calculator. When I do, I get a 16.575. Okay. All right, now 16.575, that is not a number that's between 1 and 10. So I've got that situation again. I need the decimal to be here instead. So I need to make that number smaller. I need to divide. I need to have it be one place smaller. So I had to kind of divide by 10. So you could be thinking, since I needed to go one place making the number smaller, that I need to add 1. Some people do that to get the 10 to the negative 6. Okay, so if that makes sense to you, do that. But I think for most people, it works out good to think about how 16.575 would be the same as 1.6575 times 10 to the first. But you already had 10 to the negative 7. Sorry. And so the 1 and the negative 7 we could add to get our negative 6. Now we're in scientific notation. Now this one did say round the decimal part to 2 decimal places, so once I get it finished, I'm going to go to 2 decimal places. It has a 7 after it, so I'm going to bump that up to 1.66 times 10 to the negative 6 power. Okay, and I've rounded, so it's approximately that. All right, let's try another one. So on this one, I'm going to use my calculator to do the 8.6 times the 9.7. Okay. Then when I put together the 10 to the third and the 10 to the negative 6, I know I can just add those exponents. 3 plus negative 6 would be negative 3. So the 8.6 times the 9.7 turns out to be 83.42. Okay. Well, I need the number to be between 1 and 10, so I need it to be 8.342. Okay, so for that to be equivalent, I would need to have times 10 here for those to say the same thing, 10 to the first there. Okay, but I already had a 10 to the negative 3, so those two multiplied together, I could add the exponents and get a negative 2 power. Okay, so that's in scientific notation, but then I need to round to 2 decimal places, so that would be about 8.34 times 10 to the negative 2 power. Okay. All right, now dividing is kind of fun as well. All right, so to divide two numbers that are in scientific notation, what it's telling you is that you can divide the numbers to the left of the power of 10, and then you can use the rule dealing with having a quotient. So you remember how you subtract the exponents when you have like a x to the 5th over an x to the 2nd was x to the 5 minus 2? That's what we're going to use on the power of 10 part. So the 10 to the 6th divided by 10 to the 4th would be 10 to the 6 minus 4, which would be 10 to the 2nd. And then we can do 9 divided by 3, which is 3. And so that one would be 3 times 10 to the 2nd. Pay attention on homework how they want the final answer. This one wants the final answer in scientific notation. Okay. So let's do that here. So 9 divided by 2, 9 divided by 2. So I did 9 divided by 3 and got 3. 9 divided by 2 would be 4.5. And then I would take the negative 3, the top exponent, and subtract the bottom one. So it's 4.5 times 10 to the negative 8th power. Okay. All right, now here, okay, could do the same thing. Do 1.2 divided by 4.8. And you could just do that on your calculator. Okay. I mean, 1.2 over 4.8. 4.8 is 4 times 1.2. If you noticed that and you knew that that was the same as 1/4 right here, you could make use of that. So that would be 0.25. But in reality, you probably would just do 1.2 divided by 4.8 real quick. When you do, you get that 0.25. Then you go over here and you take the top exponent minus the bottom one. Be careful, we got minus a negative 4. So remember that's negative 5 plus 4. So that's going to be 10 to the negative 1 power times that times that 0.25. Okay? All right, now you need to watch it because that number is not between 1 and 10. So you're going to have to make that 2.5. So be careful on this one. This one's, we haven't had this happen before. So 2.5, the decimal, to have that equal 0.25, I would have to move the decimal one place to the left, wouldn't I? Okay. to make those equal. All right, so 0.25 would be the same as 2.5 times 10 to the first. So now this and this are equal. But we already had a 10 to the negative 1 there. So I need to put those two powers of 10 together so I can add those exponents and get a negative 2. And then my answer would be 2.5 times 10 to the negative 2 power. All right, now that is tough. So don't forget that sometimes people will do this. Sometimes they struggle with that. So what they'll do is they'll take that and they'll write it in decimal form. So they'll take that 0.25, and if you're multiplying by 10 to the negative 1, that's going to make the number smaller. So this is the number you're trying to put in scientific notation. Then they go from there and they say, all right, so in scientific notation, I want the decimal to be here. So that would be 2.5 times 10. And I've moved it 2 places, and this is a small number, right? It's a smallish number, so I want it to be 2.5 times 10 to the negative 2 power. So feel free to do that if you want. If this is a struggle, if this is a little confusing, okay? Feel free to just put it in decimal form and then change it back to scientific notation, okay? All right, let's go ahead and do this one application. All right, so this one says Earth's orbit around the sun is not circular. So here's the sun. And then we've got the Earth orbiting around the sun. So that's the Earth right there. And it says it's not really circular, but it's close to it. And that the radius, which means from the sun to there, the radius of the circle would be 9.3 times 10 to the 7th power. Then it wants to know what's the approximate distance, and they want it in scientific notation, that the Earth travels in 1 year. All right, so the idea is in 1 year, okay, it's going to go around the sun. Okay? So what we're going to need to do is use this formula, circumference of a circle. So the circumference would equal 2 pi, and then in place of the r, we're going to be putting 9.3 times 10 to the 7th power. Okay? So let's use the approximation that pi is about 3.14. So we have 2 times 3.14 times 9.3 times 10 to the 7th power. So let's multiply these all together. So I'm taking 2 times 3.14 times 9.3, and that gives me 558.404. Now it wants the final answer. First in scientific notation and then in decimal form. So this number isn't in either one. So I'm going to wind up rewriting that as 5.8404 times 10 to the first, but I already had a 10 to the 7th sitting there, okay? And so in scientific notation, I would have 5.8404 times 10 to the 8th power. Now, really, this is implying that we have more accuracy than we really have, okay? It'd be okay on that, like if you wanted to round quite a bit, you could. They didn't specify how to round, but you could easily just say, so, that's about 5.84 times 10 to the 8th, or even go so far as to say 5.8. Okay. It's approximate anyway, because this is approximate. All right, now, that hard part, getting from here to the true scientific notation form, can be the hard part. So you might want to go from there over to decimal form. So take that, okay, number that you had, and multiply by 10 to the 7th. So that's going to move the decimal 7 places, 4, 5, 6, 7, and fill in with zeros. So the decimal form of it is this, okay? And then go and double check that your scientific notation is correct by now putting that back into scientific notation. So the decimal is here and you want it there. Okay, and that's 1, 2, 3, 4, 5, 6, 7, 8 places, and it's a big number, so it's going to be to the positive 8. All right, so you see your options on how to make sure that you get this situation taken care of. You can go to decimal form and then write it in scientific notation, or if this makes sense, see how we had to make the number 1 place smaller, so we had to wind up adding 1 to my exponent to adjust for that. Okay. All right, so they wanted the scientific form, and they really didn't specify to round, so you probably would have left your answer as 5 point, let me get rid of all these extra circles and stuff and clean it up a little bit. Okay, so on this one, your answers for scientific notation, when they ask you to type that in, you could type this in, and then if they said decimal form, you would have typed in all of this. 5, 6, 7, 8. Okay. Get rid of that little decimal. That would have been the decimal form. That would have been the scientific notation. And watch out if they ask you to round to 2 decimal places or something, follow those rounding rules if they had asked you to round, okay?